So when we design these projects, we do quite a bit of computer modeling. We do hydraulic modeling, and we look to see what the impact of the projects are. And we realize that the river does want to move, but the other flip side is we are in an urban environment, and there are places we probably don't want the river to move. So those are areas that where we want to harden that infrastructure, but at the same time, are there ways that we can incorporate vegetation at that point? But basically, the point is, we don't want riverbanks moving so that you're affecting your roadways and utilities and that sort of thing. So where we allow some movement, obviously, if there's not a whole lot of infrastructure that's at risk, that we could allow for that, right? So interesting. I know when we were doing one of our projects, Discovery Ridge, the Elbow River upstream of the city, I had the privilege of just seeing the aerial photographs from the 1940s all the way till current, and it was amazing how much the Elbow River has just meandered all over the place up in that area. One year it's here, and another year it's moved all over, right? Into that whole riparian area. It's dynamic, right? So once you start building infrastructure along those rivers and creeks, that's when you get into trouble, right? So anyway, this is the Inglewood project. So we'll probably step off the bus here, and I'll maybe just walk towards the river here.
Is this the best method, like so far that you know of, like managing erosion, or are there others and it's just like the most cost-effective?
I wouldn't know. There's probably a lot of different techniques, yeah. But this one was again one of our critical erosion sites, so we had to respond fairly quickly.
So
so timing was one of the main factors in this particular project.
Yeah.
So other projects where we had more time, we came up with more different designs in terms of bioengineering and that sort of thing. Yeah. So maybe I'll just kind of rephrase the question. So one of the questions was, is this one of the best techniques to prevent erosion? And there's probably a lot of different ways to have riverbank erosion protection. But in this case, because of the timing, because this whole area was at risk, we didn't have the luxury of a lot of time to come up with design and that sort of thing. It was more about, and I believe during the flood they were actually placing rock at certain critical locations. They didn't do the whole bank. They just put in some rock at a few critical locations just to help divert some of that energy away. So, and then basically we came back later in the summer and finished the project, right? And did a permanent project. So initially, I think they literally put in rock just to help prevent further erosion during the actual flood event, and then later. So in terms of this particular site, prior to the flood, the riverbank would have been much further out to your left here. It would have been probably another 20-30 meters this way, and that's why some of the people with the homes right in front, they had that beautiful green space in front of their home prior to the flood, and when you lose something, you kind of want it back, right? But in this case, it just wasn't feasible to do that. So and it was almost like a vertical wall, right? Like after the flood, you saw the photos, it was fairly vertical. So over time, if you did nothing, it would just literally fall in the roads, right? So I witnessed that at another project, Carburn Park. Actually, it was June 2014. It was the year after the flood. And so we got a call from Parks, and they said, hey, we're having an issue with this Carburn Park, which was initially a lagoon. But during the flood of 2013, it got blown out. The lagoon got blown out. So now it was the river, and the riverbank just wasn't protected that well because it was never exposed to the river. And then so in the higher flows the following year, it just started eroding away, and it literally fell away. And we had there was a pathway, and in the matter of an hour that I was there, I saw the actual erosion happen, and that was a very small event. Like, it was just a repercussion from the previous year flood. It exposed this area, wasn't protected properly, and we had just a small event on that the following year, and it just fell in. So in terms of the power and of the water is quite impressive. So in this case, this whole area, like say about probably 30 to 40 meters, maybe even 50 meters wide for this whole length, literally got washed away in a matter of hours, probably 24 hours. So the water just wants to keep coming straight, like it just wants to keep going straight here. So of course the riverbank's here, so it's diverting that energy, but it just started eating away because of that energy, right? And then, like I said, every cubic meter of water is 1,000 kilograms, right? So, and this one, there was about 2,400 cubic meters per second at this point. This is downstream of the confluence with the Elbow River. So, so the energy here, and like I say, most of it would have been concentrated on what we call, in this case, the right bank. So when I say right bank, left bank, just pretend you're floating down the river. So that's, yeah. So the right bank here, this is where all your energy would have been concentrated. And the left bank, there's a whole new gravel bar there, like, so less energy, right? Yeah. So it's depositing stuff because the waters are slower, so it's depositing things. So that's how rivers kind of meander, right, over time, and that sort of thing. So
how do you know when you've put enough down?
That's a good question. So the question is how much do you know, or when is it enough for rock? So every project is or every site is unique. So we look at the project. So in this case, I'd have to confirm, but I'm sure the rock level is at what we call the 5-year level. So we use statistics, right, to figure out, okay, well, the river for a 5-year levels here, 20-year, 100-year, whatever, right? So, and in this case, my guess is there was probably a 5-year event where we wanted the rock to be at that point. So that way, so anything below a 5-year event, the rock is going to be here and stabilize. So, and then anything above that, we still want protection, right? We still want some plants and stuff. So the plants that we would have planted here likely would be willows and shrubs and that sort of thing. So in the event that part didn't survive the next flood, you know, it's probably a little bit easier to replace but the rock should stay, right? The base, the important part is that the base is going to stay, right?
That keeps the main velocity of the water further out to some extent.
Right, and so what these are just kind of points where the rock has been placed on purpose, again, to divert that energy. So again, that energy coming straight on, so the idea is to help divert some of the energy back to the center of the river. And then, like I say, we use kind of the hydraulic computer models and say, because if you do this, then what's the effects downstream? You got to be careful where you're diverting that energy, right? Yeah. So if there's infrastructure on the opposite end or opposite side, you got to be careful that you're not going to divert all that energy and all of a sudden you haven't got the protection you need there. So there's a lot of things to kind of consider. I'm not sure.
I've got a question, Chris.
So as the flooding's actually happening and we're getting calls from residents, and we're trying to manage all of these critical sites as they're happening, right? So the bank's falling away, we got a fire hydrant sticking out from a pipe, just kind of hanging out into space here. And, you know, how do we stop the erosion when the event is going on? And so there's this, it's not really a panic situation, but we don't have the stockpiles that we've used to do all of this structure that you see now at the time the event is happening. So we went through our stockpiles really fast, right? And we've got truckloads of material heading to different sites, and we're just backing up trucks and dumping it off the bank to try to build something that will divert the flow and deflect the energy that Renee was talking about. So we're grabbing, those, they're called GM barriers. Do you know those concrete barriers? They're about this high, and they're, we just started chucking those in trucks, and we're hauling them over here, and we're chucking them over the edge. And we're the crews are standing here as they're dumping them. There's such force in this river. They're dropping them in, and they're going like that. And they're going, are we doing anything? Is this going to help? So you might be dumping here, and the pile is actually starting down there. And so, it eventually built up to enough of a pile. And we had some pictures, I didn't even think of showing them, but we have some pictures after the waters receded of that pile of GM barriers here that kind of stopped that continual erosion and prevented that roadway from collapsing into the river. So that was kind of the emergency part of the response. And then afterwards, of course, it's designing something that's going to be, stable for a long period of time. So we have an opportunity here, because we do have an outfall right behind us, to kind of talk about some of the challenges that we have with a river and a storm system that drains to the river. So one of the things you can see is this little tube sticking up from that outfall. That's an indicator that we actually have a gate on that outfall. So one of the challenges for us, especially during the spring runoff, is the river elevation changes, right? So it gets deeper. And what you'll notice is the community, so we've got a bit of a berm here that protects the Inglewood community from high river flows. So it's lower behind the bank. And you'll notice the outfall is actually down at the normal river level. And so when that river rises, it wants to move that water into the community at the same level as the river. So one of the ways we can protect the community is with these outfall gates. But there are some areas that we either weren't able to get to the outfall gate in time, or the actual outfall doesn't have a gate. And it means that's a way that the water can be conveyed back into a community and cause flooding. So that impacted several areas in downtown Calgary during the event. We had water actually migrating back through the storm system and coming up through catch basins and manholes and situations like that. So there's a lot of flood resiliency projects that involve outfall gates and our ability to stop flow coming in. Now, the challenge with that, and we experienced this in one of our communities called Sunnyside, is what else is going on while the river's flooding? Storm events, right? It's our rainy season. So you got an outfall gate that's closed. You got storm water falling in the community. Where's it going to go? It can't go anywhere, right? It just pools into the community. So that necessitated a need for a whole pumping plan, right? So we bought some portable pumps that are on trailers that we can move around where required. And we might have to set up in an area like this where the manhole is down there, and then pump the water over the bank to keep the storm system functional while a storm event happens. So a number of different challenges happen when you're trying to control nature.
What's the capacity of them?
There's 6 critical sites, 27 high priority sites, and then I think we've had about 10 moderate priority sites. So, and then low priority sites. So if there's a little bit of erosion, it's probably not going to be a huge issue. So we'll probably just kind of monitor them at that point. So it sounds like, I'm just trying to remember the numbers here. So it sounds like we've probably done 35 to 40 projects. Well, this one,
He was pulling a politician thing there. He didn't answer the question.
yeah, this one, I don't know the specifics of each of the projects, but it could have been $2 million or more.
It's built up on that side. You tend not to kind of try and just...
There's a few regulatory requirements when you start moving gravels around. If you get a little bit of erosion at the toe, the rock will just fall in on itself, right? So it'll kind of it'll kind of protect itself to some degree, right?
For you to do work in.
So the question was about how come we can only work in the river certain times of the year, and that is from a federal and provincial regulatory perspective, and it's mainly for protection of the environment, like fish habitat, and primary fish habitat, right? So, but there would be other factors involved with that too, probably bird.
It's the spawning season for fish.
Yeah, and different fish have different spawning seasons as well. So unless you get special permission from the agencies to actually work in the river in those outside those periods. Our group, River Engineering Group, they're working with a consultant right now, and working with both the federal government, DFO, and the province on creating a model for, and they call it a habitat suitability index model. And so initially when we did these projects, like for example this project here, okay, you put all this rock in, you need to compensate 1,000 square meters, or actually might be 5,000 here, I don't know, 5,000 square meters of fish habitat that you've lost because of this rock that you've placed. So the DFO says, okay, that's 5,000 here, 6,000 here. Like for the projects that we actually did, it was in the order of 60,000 square meters of fish compensation was required. So that's 6 hectares. Like that's huge. And so what we did, Frank's group and Jonathan Slaney in particular, they're creating this computer model. And the idea is, instead of just area, it's basically looking at, it's giving points for different habitat for fish. And they actually looked at different species of fish. So, and then at what time of the year they spawn, and what they need to spawn, and what they need for their whole life. And they give points or take away points depending on the criteria. So they've developed this very sophisticated computer model, and basically we're on board with the federal and provincial agencies to say, yeah, we like this model. And now they've come up and they modeled the river post-flood. So after the flood, they said, okay, this is what it was before any work was done. And then they modeled the work that we did. And then they compared the two models and said, okay, you need to provide X amount of WHUs, which is weighted habitat units. So instead of an area, it's an actual unit. Like they're just going to weighted habitat unit. And so now we're looking at doing fish compensation, and the idea is we're going to be basing it on these units, WHU, WUs. And so that way, when we actually create a fish compensation project, instead of just a random area, we'll actually be able to put it in the computer model and provide some information, say, well, this will provide X amount of units. And so it will be providing, we'll be basically meeting the criteria from the federal government. So I thought it was about 150,000 units that we had to replace or provide. So we're looking at least two projects, and we're hoping that that'll be enough to provide the compensation requirements from a federal perspective. So
What do those kind of look like?
sorry?
They go up.
And
It's
what,
density.
in any way, just trying to understand flow and things. Surely the logic of this is slightly problematic in that the river's heading down here, straight in. So, and with that there, it is.
The actual outfall was sitting way out there, and the bank is now back here.
Yeah.
You know, so it's this dynamic environment.
Yeah, that's
but
changing.
But if you look at this one, I know they're going to leave here. But it's still above the flow.
Yeah.
Kind of the average flow. It's still higher. But yeah, when that flow comes in, and that's why we have a gate here.
So in terms of the first things that we usually do is we get a kind of a conceptual idea of what we want to do at that particular site. And then we usually try and arrange a meeting with the agency, either the provincial, usually it's the provincial agency, the Alberta Environment and Parks, and to get them on board onto why, what's needed at this particular site, and try and get buy-in from the agency so that when we actually put in the approvals or the submissions, that they understand what the basis of the project is. Because in some of our projects, we've kind of it's been back and forth with the agencies, in terms of what they want and that sort of thing. They kind of frown with rock. And understandably, there's not a lot of the rock does the job, but it's not very pretty and doesn't create habitat, right? And so, but sometimes that's the best solution for that particular site. And there was one along the Elbow River where the agency was saying, well, we want timber crib walls there, but we did the modeling and it wasn't conducive. It wasn't a good location for the timber crib walls because of certain factors. And so it was kind of a back and forth with the agency to say, no, the rock is the best solution. But you know, we put in some vegetated rock there, so we put in some plants in the midst of the rock, right? So, but it takes time, right?
The development.
Yeah.
Right?
So we don't have the time or the expertise to do in-house design for these projects because, well, first of all, there's so many of the projects, and we're trying to meet them in a certain timeline, right? One of the things that we have to be aware of is the program. Like these projects are being funded from the province through two different programs. There's the DRP, which is the Disaster Recovery Program, and then there's the FREC, which is Flood Recovery Erosion Control Program. Each site is unique, so we need to kind of look at it and say what's going to work. So what might work at one site may not necessarily work at another site, right? So we've got to take that into consideration. The second one is what we call the Elbow Discovery Ridge project. So this is an area that was upstream of the reservoir. So this would have been an area that actually saw the full brunt of the 1,240 cubic meters per second coming into the city. And it's one of our first communities in the city. And I know Discovery Ridge, there was some flooding in that community. I'm not privy to the details, but definitely that community did suffer some damage as a result of the flood. And the project that we are going to go look at is where it literally eroded about 10 meters width, like a width of 10 meters for about 80 to 90 meters in length. So there was some erosion at that location, and it was not deemed critical or even high priority. It was moderate priority. So that's why we got to it this year. And this is where we actually put in timber crib wall on this particular location. And it was one of the photos that I had showed up on the screen there. And so we went, we kind of worked with the provincial agency to kind of get their buy-in before we started, before we finished the design, right? So we met with the province on site at this particular location, and when we mentioned timber crib walls, they're just like, oh wow, that's great. Like they just love that idea, like the timber crib walls, just because of the vegetative component, and it's a little, it does provide better habitat for fish and that sort of thing. The other thing we did at this particular site is we actually created fish habitat. So they're not fish condos, but they're close. So what we ended up doing is we brought in large rocks, boulders, and we also brought in some woody debris, some trees, and tree trunks, and that sort of thing. And we've kind of chained them to the rocks, this wood. So the idea over time, it'll catch some little bit of debris and sediment and silt, and hopefully over time build some pools and create fish habitat. So this particular fish habitat was to compensate for another project that we built just back on Heritage Drive and where it meets the Bow River. So. I'm just going to, there's actually a crew working right now, so I'm just going to give them a heads up.
You've never been here?
So this is the Elbow Discovery Ridge project, and right underneath the snow here, there's actually a paved pathway that is part of the kind of the regional system, I guess. And of course, you can see the transmission line right above your head for the electrical. So this was some of the things we wanted to protect. And this particular site, left bank was eroded, and we looked at different techniques, and we decided on a timber crib wall. And so this one, what they did is they basically would assemble it on the land, and then literally place it in the riverbank with machinery, heavy machinery, but before they actually did that, there's actually a layer of rock below that. So there's a bit of a rock base, and that's just so that's going to hold up the whole structure in the meantime. And that is part of the permanent infrastructure, but it's a very low elevation. Like the 1 and 2 year level would be probably a third of the way up the timber crib wall. So that rock, the elevation of that rock is very low in terms of typical elevations, right? So some of our other projects, it's been 2 year, 5 year, or even 20 year level, depending on what we're trying to protect, right? So, and I'm trying to think the best view from over here. So yeah, let's just kind of walk towards that little white backhoe here. I'll just so this is actually where the crib wall is starting, right where we're standing, and it goes for about 80 meters in this particular section. And in the photo that I took, it was probably September, October, that photo I took on the screen, and so they hadn't started putting the live willow plantings, and so they just have in the process of actually doing that right now. So amazingly enough, only the first on the vertical wall, it's only an inch or two that's frozen. So the soil underneath the crib wall is still not frozen right now. So, and that's why they're still able to work at this time of year. And I'll show you a little bit how they're doing that as well. They've got they've kind of built a custom thing to help with the insertion of the willows. So I think, I'm trying to remember how many, I think there's 3,000 live willow stakes that are going in this timber crib wall for that whole length. And if the weather holds up, they will probably be finished in the next week and a half or so. These will establish, and this whole riverbank will be much stronger. And kind of withstand some of the higher flows, right? So this is what kind of plant we want here along the river, right? We want something that's going to be strong and resilient, and it's a native. Like, we don't want to bring species that aren't going to be climatized for Calgary, because it's not necessarily our cold weather that has an effect on the plants. It's our Chinooks. We have, for example, not these types of plants, but cedars generally really don't do well in Calgary because of the Chinooks. The freeze thaw just throws them for a loop. The other component of this particular project is the fish compensation. So I mentioned the rock and the woody debris. So there's two spots. We did it kind of just upstream over here. It's hard to see there.
I see something right in here too.
Yeah, and then we would have placed some rock.
Oh,
yeah, in here.
And they're actually chained.
Yes, they're chained to the rock for now, and so the whole point is to slow the water down a bit. And even when we actually placed the rock, before we even did any work here, we placed the rock. You could see the energy. It was moving the water away from the riverbank, like just the rock, the large rocks, but before we did any work. It was kind of neat to see that.
So even all the
not sure if they're aluminum or steel. I think they're probably aluminum. Okay.
So you can't actually see the bucket from the operator, so he has to have.
Right.
Take a while.
Well, I thought, like I say, the fish compensation. So this fish compensation.
It's so beautiful. It's so
It makes such a difference in the
Yeah.
volume of the river.
Yeah. So I think, like I say, we're really happy with this particular project.
Yeah.
So.
There's so much art stuff that's like in a box until I die. You actually.
Oh, I'll send a link to Charles.
Oh, cool. So it's all online?
Yeah.
Oh, great.
Yeah, the city website. Yeah,
Oh, thank you.